Now I'm going to go through a template for solving first order. Now first order is when you've just got the first derivative. We don't have d2y dx2 here or d3y dx3, so it's first order. It's linear because dy dx is only just raised to the power of 1. So it's first order linear differential equation, and it is of the form of dy dx plus some function of x times y equals q of x. Now, it's important to firstly get it in the form of dy dx, no coefficient in the front of dy dx. So that could be the first step of the template, is to, if there was a coefficient before dy dx in the original equation, you'd have to divide right through by that, and that would change this, and that would change q of x there. So the first step could be, if it's not already, get it in the form of just dy dx by itself, plus p of x y equals q of x. So that's the first step. This uses a nice little technique called the integrating factor, and this function here that's in front of y is used to calculate the integrating factor. The integrating factor is e to the integral of that function there, so e to the power of the integral of p of x dx. We choose this on purpose because this sets up the left-hand side to resemble the product rule, which I'll talk about in a minute. All right, so the next step is to multiply both sides by the integrating factor. Don't forget, for an equation to hold true, whatever you multiply one side by, you've got to multiply the other side by. So if we go back to our equation up here, our original equation, we're going to multiply right through by the integrating factor. So this term here has to be multiplied by the integrating factor, this one here by the integrating factor, and that one there by the integrating factor. So we multiply both sides by the integrating factor. The fourth step of the process, or the template, is if we look at this here, the right-hand side just stays as it is, but if we look at the left-hand side here, basically what this has turned out to be is just the product rule. So we've got u dv dx. So here's my u dv dx plus u dash v. So here we've got the derivative. Here we haven't got the derivative. This will be the derivative of that. So we've got, so instead of writing it like that, we can say that is the same as d dx. This is my u and this is my v. So there's u dash v, and so on. So we've got equal to q of x, I of x. So we've just organised that so this actually holds true. The next step is to integrate both sides. So we integrate both sides with respect to x. Now if we find the derivative of two functions multiplied together, and then we integrate, we're back to where we started from. So all of that can be just replaced by I of x, y. So we've found the derivative, then we've integrated. So it's like if you integrate and then find the derivative, you're back to where you started from. This side over here, the right-hand side, has not changed. So we get I of x, y is equal to the integral of q of x, I of x dx. And we want y, we don't want I of x, y, we want y by itself. So we've got to divide right through by I of x, and we get y equals 1 over the integral, I of x, the integrating factor, the integral of q of x, I of x dx. So they are the 6 steps in the template to solving first order linear differential equations. The next little section I'll go through is an example of how this is done.